Hi, good morning. Today we are going to see about boundary value problems in PDE. This is in the numerical method, numerical and computational techniques. In this particularly we are going to see about Laplace equation. Myself Pushpalata from Department of Mathematics. First we have to know about what is meant by Laplace equation. That is, consider the Laplace equation, that is dou square u by dou x square plus dou square u by dou y square equal to 0 is the Laplace equation. For solving this Laplace equation, we have two types of formulas. First one is standard 5-point formula. So standard 5-point formula is nothing but first fixing the center value, the left side, right side, top straight, down straight. So using these formulas 1 by 4 into adding these four values, we get the standard 5-point formula. The next formula is diagonal 5-point formula. So diagonal 5-point formula is nothing but just fix the central value and diagonal, left diagonal, right diagonal, and also these two diagonals. Similarly same formula 1 by 4 into the central value equal to 1 by 4 into all the diagonal, adding 4 all the diagonal values, we get the diagonal 5-point formula. For solving the Laplace equation, we use the Lehmann iteration process. In this, the first problem is solve dou square u by dou x square plus dou square u by dou y square equal to 0. Here they are given the points. So first this one is u1, next one is u2, u3, u4, name it as. If they are not given the name, we just name it at u1, u2, u3, u4, u5, u6, u7, u8, u9. So all the values, all the data they are given. Solving this Laplace equation by Lehmann iteration process. So we have two types of formulas. One is standard 5-point formula, that is SF, PF. There are another one is diagonal 5-point formula, that is DF, PF. First fix the central value. Here this is the U5 is the central value. First we have to use the diagonal 5-point formula for the straight values. Left value, right value, top value, bottom value. That is U5 corresponding U4, U6, U1, U8. These values we use S of PF. The diagonal values U1, U3, U7, U9. We use diagonal 5-point formula. So let U1, U2, U7 and U9 be the values of U at the 9 interior mesh point. So just substitute the values. That is U5 is the center. We use the standard 5-point formula. So 1 by 4 into adding those values. Similarly, standard 5-point formula is for U2, U4, U6, U8. This is standard 5-point formula. The another one is diagonal 5-point formula. Why we are finding this value means these are the initial iterative values for getting the final value. So for this we use the Gauss-Seidel iteration scheme. What is meant by Gauss-Seidel method? Just we have to substitute the initial values. If we getting the new values, then omit the old values. If we getting the new values means omit all the old values, we get the new values. So first we have to next iteration. The first iteration is UK means the next iteration is k plus 1. Next k plus. First we have to find out the value of u1 k plus 1. So k plus 1 is we have to find out the value of u1. Here we have the using the u2 value. So here not k plus 1, we get k plus 2. Next we are here using the value of u3, you have to find out the value of next iteration. So similarly find all the iterative values and put in the tablet column by similarly Gauss-Seidel method. Already we saw that Gauss-Seidel method. So similarly repeat the process. Substitute the new values and omit the older values and substitute the new values. If we get the values and the two values are similar, we stop the procedure and then write all the values. Thank you.